Okay, thank you very much, and good morning, everyone. Today, of course, I'm trying to share with you some of my thoughts on basically, as you can see from the title, the sun, the monster CO2, and then the Earth climate. In between that, we'll bring in Galileo pretty much very early in the scene. That's the reason because Galileo, as you know, in 1609, pointed his telescope to the sky and then sort of changes everything. And just a bit of trivia, since we are pretty much aware that we humans is all this mighty power. Does anybody know that actually if you take the geometric mean of the mass of the sun and the proton, guess who's standing in between there? It's basically 50 kilogram, roughly, plus or minus factor of 2, which is human, basically human in between there. And the key point that I wanted to mention today is basically about this mess on CO2. Really, it's a monster. As we know, monster doesn't exist really in that sense, but it's a very troublesome monster. The monster is that, as you all may know, also, in fact, I would say every single one of us in here has been called climate deniers of some kind. But I think that it will be a lot more dangerous if we deny these three facts. Okay, these three facts are pretty much that I don't think that one could change. Either way, if you have even the Environmental Protection Agency, which is really strange, I don't know whether they're really protecting environment. So the fact number one is that indeed CO2 is not an air pollutant, as I guess the US Supreme Court has ruled in April 2nd of 2007, almost April Fool jokes. And it is certainly food for plants and marine life. And I'll show you some evidence for that, of course. And one really need to talk about everything based on evidence and in the spirit of Galileo too. And then the second point, which is very, very important, because this is also very, very timely, because this is in a regime that we are crazy about controlling carbon dioxide now, having this cap and tax scheme that is really, really a bogus one, that is really, I have to make a disclaimer, since I'm going to make some strong statement. Anything that I have to say here has no relation to anyone or anybody except for myself, all right? So it has nothing to do with any institution that I belong to or whatsoever. I'm a free person. So atmospheric CO2 level are really indeed controlled by temperature and other biological and chemical variables, not the other way around. This is really, really a very, very important point, and I want to show some example on carbon dioxide level at Salt Lake City to try to give you an essence of how carbon dioxide really recycling around the Earth system. And then finally, really a most important and really a foolish thing that invented by Gauss and IPCC and most of these politicians who are so anxious to try to govern life and govern the world, which is the idea that there is these things. If we just lower carbon dioxide, like, not breathing in this room, the temperature all of a sudden going to get cool, okay? So they are introducing the idea essentially that, if you cut CO2, guess what? CO2 is a greenhouse gas. If it's too much of it, it's going to kill everybody, going to make the Earth so warm, in fact, make Venus, that nauseous place. And then if you cut CO2, all right, you're going to decrease the temperature, okay? And then everything will be better, all right? And then, so they're suggesting that there is such a magical CO2 knob for controlling weather and climate, which simply doesn't exist. And of course, in this context, I want to show you essentially the theme, which is part of my favorite subject of research, which is the role of the sun in the climate system, which is really, really highly ignored, okay? And highly ignored for some very, very strange reason. I felt that it absolutely had nothing to do with science simply because they refuse to look, okay? And then instead they invent this CO2 monster. So let me start. Here's that carbon control knob now, right? You just adjust it up or down, we'll get all the temperatures and in fact less droughts for all these poor Africans, and less sea level rise for the Bangladesh people. All this problem will be solved, okay? And less Hurricane Katrina and all that stuff. In fact, less snow on Al Gore's house. Let me start the talk by trying to introduce to you the theme of Galileo. Galileo, as we know, is among one of those pioneers in the history of science, really. He's quite a very, very remarkable person, really, by the way. And here I'm showing an image of Galileo, and this is fall of 1609 in Padua, Italy. And he was really not so happy with his life, He don't have a government job, so he has to really work very hard teaching students and all this stuff. But around basically May of 1609, he heard some rumors that these Dutch people know how to make this spyglass. Okay, essentially, it's the idea of a telescope. But by August, he already kind of be able to master the principle of optics and try to make small scales telescope. That one is only a power of 8 telescope, by the way. So he's been making that telescope and then sending out to a bunch of people. In fact, in August, he was actually selling it, essentially selling the ideas and showing it to the government of Venice. Okay, and then this is actually the 20 power sort of telescope. Only 2 remaining one available in History of Science Museum in Florence. The top one actually is in Franklin Institute right now. It's an exhibition or celebration of that 400 years anniversary of Galileo pointing the telescope to the heaven. All right? And there's a lot to say about this particular telescope. But one of the things that he actually first pointed to is actually in December of 1609. It is, of course, the subject closest to us, that little rock closest to us. Scott Carpenter knew all about this one. And it's the moon, of course. And it is so remarkable, actually, about the way, the details that it was into. And then, of course, finding the facts that, this sphere is not that perfect, smooth sphere, and it's very rough. It has mountains, it has valleys, In fact, I was telling some kids that there was maybe even dust storm, but you won't be able to see that, of course. But it's so remarkable in the sense that one can compare the image, one of the image that he painted and draw and eventually published in March of 1610, and that it's really very close. One can try to see some of the features that he was showing on this. Okay, so it's a very, very remarkable work in the sense of science. All right, but then I really think that the true contribution and the effects of Galileo's on everyday's life is just almost too obvious. I mean, in 1612, this is his personal friend Ludovico Sigoli already really replaced actually that usual image of the Virgin Mary with the smooth sphere moon below it, now with the real image of Galileo's image that was published in the book, right, in 1610. So it's really everywhere Galileo's influence, even as of today, I'm quite sure. Now I'm going to point to this page. This is probably the most exciting, I would say, single page document in the history of science. This is actually essentially Galileo's note, but it's the transcribed one. The original copies, I think we only have basically for January 13 and 15 stored in University of Michigan's library, but the original is not there anymore, but these are transcribed, people copying from all the note that he has taken. But some put that in one page, starting from January 7 until January 15th. And then this is basically his observation of pointing the telescope to Jupiter. All right? And it's really a very remarkable document, and it's really, really very exciting if you really to follow the note, which I'll try to explain some of it to you. Okay? So by January 7, Galileo already started pointing to Jupiter, and he find the position he kind of noticed that, hey, there are these 3 stars around next to Jupiter. Okay? Kind of weird, okay? What are they? And then it's so funny that January 7, that day itself, he happens to write a letter to someone, which we're not sure whether it's the Medici or another person, that he wrote a letter there describing this observation that's so exciting that he was getting images, nice images of the moon, and then he was saying that, hey, I'm going to use this, I saw stuff for Jupiter. So happened that he wrote that down, so he had to write the letter. So next day, he's just curious. The next day, he go and watch it again. Look, the Jupiter at a different position now. So things really change. That's interesting, he say. So, what's happening? At that time, remember, no one has ever seen even a resolved image of something, right? I mean, he really saw Jupiter's, and then he now see all these stars next to it. He don't know what it is. And then January 19 was not mentioned, but it's in the note, it's cloudy, so he was so anxious he couldn't see anything. By January 10, he was able to point to Jupiter again. He see, position change again. By January 13, he saw the fourth one, actually 4 stars around it, okay? And then he even said, better yet, this is another more accurate way of pointing this. So he make another image here. First he draw this and he say, better yet, I'm going to have this one, all right? And then by January 15, he clearly solved the problem. He realized that these things really, really is basically moons around Jupiter, okay? This is the 4 moons of Jupiter. And it's so amazing that on January 15, when he was watching this, towards the midnight, the next page, guess what happened? All of this is written in the language, standard language, Italian. The next page, still the same night on January 15, he was still observing it. In fact, he saw one of the moon actually disappear, so there's three stars around, 3 moons around. All turned into Latin, which is really the universal language of science, and then he realized that this is the time to really get a real government, a real secure job where he can really not worry about teaching so much, so he can really learn about how nature really works. So this is actually his application for jobs, right? He's really describing all these downs, and the whole idea is that to keep watching this system and then formulate the idea that indeed science is not a matter of speculation or anything, it's a matter of observation, taking data, and then try to make sense of what the data is telling us, okay? So in fact, this is really a revolution in some sense. Because at that time, as you know, we still kind of don't believe in the Copernican system of how, everything is going around the sun. Now he actually is able to show that, there are actually things that's going around Jupiter, right? Essentially, we'll know that also moon is going around Earth. So 4 moons he really discovered, but by January 15, there's actually a note that truly confirmed he realized that this thing is actually going around the Jupiter system. And was able to see actually the occultation on January 15 itself towards midnight and change everything. And this is actually stuff that is taken from a colleague of mine, which is shown here. His name is Owen Gingrich. He's one of the very, very fine scholar of a historian of science. He's also trained as a solar physicist, of course, in the 60s and 70s. Since then, I guess he thinks the sun is too hard to study, so he get into the more interesting stuff on history of science. Anyway, he went to Vatican about 2000s, and then he was asking the Vatican folks to show him this particular page, and where he opened up to this page, and then this is actually the summon to try to integrate Galileo, as you know, was eventually put in jail, but not really in jail, is house arrest for the rest of his life, and so he was doing, according to the church, that is a heresy, that the stuff that he was talking about, and then it was subject to integration that subject to torture even. But at that time he was already 70 years old, so no one tortured him really, but he was put into house arrest. Okay, essentially by really disobeying what the church is teaching on the Copernican system and thinking about Bible not being a final authority of matter scientifics. So he was placed under house arrest for the rest of his life. In fact, almost blind by the time. And by the way, for the sun, Galileo turned into the sun around 1612 and 1613 or so, where really realizing that sunspot belongs to the sun itself. So with these new tools, he was able to make so many really revolution in that sense, right? But really also, if you think about it, did really Galileo have enough evidence to try to prove actually the existence or the correctness of the Copernican system instead of the old system of Earth Center or the Aristotelian cosmology? Really, he doesn't quite have the evidence, okay? There's no way for us to distinguish, even at his time, between this system, which is the correct one as we know, and this is the old system, right? That we really don't know enough of it. So essentially, the role of Galileo is just, in the sense for science, is to try to demand physical evidence and observation and the methodology of doing science, really. That is really, really important. So he really did not prove the motion of the Earth or the Copernican system itself, but he just simply made the whole issues intellectually respectable. So he changed the way of how we do science. And then one can really easily argue how science really works, right? Because no one really had the master all the knowledge at that time. We really don't have all that evidence. So science really essentially still works by persuasion and not by proof. I would argue it's similar today, and it's particularly worse for the situation of climate change and CO2 and all that, and we'll see some example of that for sure. Here's the way persuasion works. I mean, as you know, the global warming issue is so big now, it's even infected my field, which is astronomy. And astronomy picture of the day is around April 2009, give this image, right? In fact, actually showing the computer projection of how the temperature will be by the year 2070 and 2100, how the globe will all completely warm up, okay? I think Galileo would be really, really angry about things like this. It's really weird. But what's happening to the climate system, all right? What is happening right now? Here, I show you basically what the atmospheric CO2 concentration is doing right now. Roughly from 1995 or so to 2009. It's been rising. Indeed, it's been rising quite rapidly. Okay? Now let's follow the rule of Galileo. Let's check if these people say CO2 is such a powerful greenhouse gas. First of all, no one is denying that CO2 is a greenhouse gas, period. That's it. It's really a greenhouse gas. The question is that what does it do to the system? That's the whole thing. And these people say that it will drive the temperature, right? It will drive the temperature to extreme level in which that humanity will not be able to survive. But what is happening to the temperature? The temperature really didn't follow. Just from these two observations, there's still another if, okay, subject to the point that the data are all correct, which in fact there's no chance of this data being incorrect at all. It's a correct data. Now what you got here? A very simple logic. You don't need any science to do this really. If these people keep claiming that CO2 is a powerful greenhouse gas, and then if you add more CO2, which is that we can prove that the CO2 is increasing, then the net effect would be is that because the greenhouse effect must only warm, then the temperature should really warm up, but then guess what? The temperature did not warm, right? So you have a conclusion that you can really draw that CO2 is not playing any role at all in the climate system. If it were to be so, temperature should follow. So just by logical deduction, I think one have a very good answer to some of this question. It's actually been puzzling a lot of these IPCC scientists now. Now they're trying to say, oh, we have predicted this. We have said that it should not be warming all the time. Since when did they say that? Okay? We have documents to prove that that's completely not true. And they're just now trying to rescue their fake hypotheses, which haven't even got one hypothesis to make anyway. Now, we have even more powerful evidence. As we all know, 2 gallons of hot boiling water contain 2 times more heat content compared to 1 gallon of hot boiling water, where the temperature is the same, right? Boiling, okay? Right? So, another better way of trying to measure the Earth system is basically how to measure the total heat content in the system. Here we measure it in the ocean. And since about 2003 or so, indeed we do have that kind of data. It's a system of data that is really, really very clever. It's actually a float, about 3,000 or so of them, spread all over the oceans, coming from the surface, actually drop down to about 2,000 meters, in a matter of 2 weeks or so, and then come back up and then send information back so we can record all these things. So we now, for the first time, have a way in which we can measure volumetric, the whole volume of the ocean. In that sense, you can get to the total heat content of the ocean. And guess what happened to the data? The data, the trend, from about 2003 to 2009 or so is actually trending downwards. And then if you ask yourself, what are they actually predicting, the projection of adding more CO2 to the system? It's actually going up, of course. In fact, the margin of the thing is so big now, I really think that this is one of the biggest headache for them in that sense. If you were to call this headache, for me, this is just facts. What the facts show is basically CO2 is not doing much to the system. It didn't affect the heat content to the system, okay? And it actually was going in the wrong direction. So the hypothesis is really kind of wrong in that sense. Worse yet, we know that famous person by the name of Jim Hansen from NASA GIS in 2005, in fact, says that he got the smoking gun. The smoking gun to basically what the CO2 is doing to the climate system. Indeed, he was trying to argue that, hey, we now have evidence, solid evidence, you say, for 1 decade of increasing ocean heat content from 1993 to 2003. All right? So therefore, he has verified confirmation of the AGW hypothesis, which is the anthropogenic global warming hypothesis. And guess what? We use the same criteria now that they used to support the hypothesis can now be used to falsify it. Okay? So I think this is pretty much a very, very bad situation for those people who want to keep arguing that CO2 is doing that. Right? It's going to warm the globe so effectively. So I really see that we really, really got a little problem with that. And now I just simply want to remind everybody what methodology of science should be. And in fact, Galileo is the one that pioneered all this. No amount of experimentation can ever prove me right. A single experiment can prove me wrong. This is really, really a very, very deep kind of a statement of somebody who really appreciates how science should work and what it should be, really. And I'm really very troubled by the situation that we're in now, right? And in fact, it's created almost by some of these so-called scientists around. In fact, I couldn't use the word scientist for those guys. They're essentially pseudo-scientists in that sense. Well, this is an image actually taken from Howard Hayden, who gave me this about Venus. There are some connection to by the way, Galileo too. Galileo was also need that evidence of watching the Venus, the phases of Venus, how it changes, so that he can try to sort of deduce this Copernican solar system ideas. And this is the thing that, of course, 10 things that you can do to get rid of the atmosphere of sulfuric acid in Venus. Okay, and then remember the bottom part of it. Could global warming raise the temperature from 800 to 900 degrees by 2050? So that's the question. I don't think so. Now I come to the part where I try to tell you that CO2 is really food for plants and marine life. There's no ifs or buts about this. This is the kind of biological facts that no one can change it. I mean, you can have somebody coming down here. It's still the truism that biology-wise, okay? And what I'm showing you is a chart that I'm sure you all are familiar with, but let me walk you through this chart again. It's basically showing you a collection of about 280 experiments, okay, that is showing you how the plant system of different species, different conditions, of its percent growth enhancement from about 0 to about 200%, and then putting this experiment at 300 parts per million, 600 parts per million, and 1,350 parts per million, okay? Basically 6 sets of experiment. And the bottom one is the blue curve that we connect the line is basically showing you under experimentation where there's under no stress, this particular plant system, meaning that nutrients and water are almost unlimited, so they have no stress, so it's very unreal. And then the top part is more similar to the real world condition where sunlight, nutrients and all that are really stressed and limited in that sense, so more similar to the real world. So the tendency for the real system should be more towards the upper end of it. And then on top of that, I added today's level roughly. It's basically 380 parts per million. By the way, this is mostly for the kids. Do you know how many percent is 380 parts per million? Want to make a guess? How many percent is carbon dioxide? If you get a volume of gas right here, how much is 380 parts per million? How many percent of it belongs to CO2? Do you know? 0.04%. So that's basically 4 pennies out of your $100. That's people are telling you that this amount of CO2 is going to really kill the planet. In fact, I think to the contrary. But my whole point is that people keep asking, why don't we just restrict this human component of CO2 anyway? You know what the answer is? The answer is, what about this ecological crisis that these folks are trying to introduce to the world? Really? Who's going to be responsible? Because we know that the plants really prefer to live in this regime of very, very high CO2 level. And these folks are telling us that we should keep all the CO2 down on the ground and pay a lot of money for it. And then, well, the system is going to be starved from actually the biological system, the plants. If you worry about food production, I really think that this is completely a wrong direction to go. And who's going to be responsible for that? Would Al Gore really be volunteering himself to pay all the money to do all this problem? I mean, I really think that this is the true answer. CO2 is food for plants. Why do we want to control and limit it and put it down on the ground? And this is why even the coal power plant who try to play with these ideas of carbon sequestration and storing is just ridiculous and really silly. It's to the point where, it's just politically convenient. We got to do it because people say we got to do it. No, you don't do it because it's wrong. So this is the kind of courage that I really hope that some of you would spread out a little bit further, because one could not live life in this kind of a dangerous and crazy situation. And then for some of you who really need pictures, I mean, here's the picture. Do you really want CO2 to live in 100 parts per million or 120 parts per million? Surely we want CO2 plants to live under this very high CO2 condition, right? A picture worth 1,000 words, I mean, really. And this is experimentation. And remember, in Galileo sense, experiment means that any of you can go and do it again. You just have to be careful, of course. Not to do the wrong conclusion, so you do the wrong experiment, so you reach a wrong conclusion. One also has to be very, very careful. So science is really also a very rigorous subject that one should really follow all the rules and do all the right things. And here's the reality. Oh, but then they say, it may be good for the plants, but we are worried. We are worried because you know why? If you increase all this CO2, it's going to make the ocean and lake water, all this more acidic. Oh, more acidic, guess what? Oh, it's going to make all this marine life suffer. They will not be able to form their shelf. They will be really weak. So they all will die off. This is the kind of scare. This is actually, by the way, I call it the next scare that they're already introducing all over the place. By saying that, well, even if CO2 don't change the temperature, Guess what? They're emitting now, right? Oh, it's going to cause all this harm to the marine life system. As you know, the world is covered by 70% of the world is covered by ocean. And so this is very substantial and very, very important kind of issues. So we should be careful. And guess what? Just as recent as all this data that just published a year ago, okay, by this young postdoc from University of Southampton, who, by the way, now being attacked very vigorously. And this work contradicts the findings and show for the first time that the idea of adding CO2 and causing this calcification by the plankton to reduce, actually, instead of being reduced, could double by the end of this century if CO2 keep going up. It's completely opposite direction. All right? And as you all know, that the reason why they claim that is that because if you add more CO2, you're going to lower the pH, you make the ocean more acidic, so therefore the ocean would be able to dissolve this calcium material, therefore will harm the marine life. And guess what? We have experiments to show that it's completely opposite. The marine life, because of the buffer of this upper part of the ocean, actually not getting access to the carbon. They're really starving from carbon as well, really. And then guess what? Guess what we should do according to Galileo? Let's do an experiment, right? Let's increase CO2 and let's see what happens. And here's the answer. This is the experiment that's shown. For this particular phytoplankton, which is spread all over North Atlantic, it is one of the number one species. It's actually from 280 parts per million to 750 parts per million. What it shows is that if you increase CO2, the volume and the mass of this shell are actually growing bigger and bigger and bigger, more robustly. Isn't this a puzzle? That these people keep telling us, and then this information just basically just kind of come out a year ago. Right? These people are really telling us to commit that much a thing where all this new information could still be coming out and shock us, really. This is essentially a shock, by the way, to a lot of people, to some of us who study this more carefully, to think that the ocean pH is so complex, it's going to be governed by only CO2 is ridiculous, really, by the way. Right? And then if you look at the pH of the ocean spread all over the world, it has value all over the place, from very acidic to some basis, condition of pH level. All over the world, it's different values. And then you will find it a lot more acidics in basically equatorial ocean, where all this water from the bottom of the ocean and coming up and bring up all this, a lot of stored carbon in up and then make all this ocean more acidic. And it's just ridiculous for them to say that if we change this CO2 in the air a little bit, that's going to cause all this harm. It's clearly not going to work that way, okay? And this is why this kind of experiment could still come out and shock us. And now for the puncher. Do you guys know why that they keep selling this story? You have seen National Geographic and all this stuff where they will show you, hey, here's a shell. Okay? They call it not a healthy shell, okay? Under normal CO2 condition according to them. Then here, we increase the CO2, okay, according to them. Oh, the shell all disappear. What kind of contradiction of that picture with this picture? And it turns out that this paper also clearly pointed out that this is the problem with the experiment that they have done. Instead of letting the carbon dioxide from the air as we emitted, okay, we do emit CO2. It come out, and then instead of letting it bubbling through the ocean surface and participate in the carbonate and bicarbonate cycle, guess what happened in the experiment that showed those shells decreasing in size? They couldn't even wait for 2 weeks for the experiment to really equilibrate and do all those things. They put in weak hydrochloric acid directly. I mean, you tell me this is science? It's crazy stuff. I'm not making this up. This is all stuff that just came out. Yeah, go on. Oh, everybody's shocking. Oh, okay. But, and then now they say, oh, it's only one species. Really? I really think this whole world is a bit crazy. You keep going on CO2. So here, bottom line, CO2 is food for plants and marine life, period. Don't let Al Gore tell you otherwise. So let us now study a little bit about how the carbon really works, how it recycles around the whole Earth system. I'm showing you now the CO2 level from about almost daily measurements from 2002 or so to about 2009. And as you can see, the value is all over the place. This is actually measurement, the best measurement we have is at Salt Lake City. From about 370 to about, in fact, some of the high points reach 600, okay? Very high. And what are we seeing here, really? We're actually seeing a very famous phenomenon that is co-discovered or rediscovered by some of our colleagues, which is Sherwood Itzo and Craig Itzo and Robert Bolling from University of Arizona State. They actually started to measure all this carbon dioxide in all this urban city now. We're actually seeing effects of what we call the CO2 urban dome that is created in all the major world cities now, where the CO2 level under especially nighttime under basically winter condition in which that the biosphere become inactive, right? That all this high level of CO2, this is actually during all nighttime. And then come spring and summer, look, the level even go way below the global level is. Actually, the line is wrong here. 385 roughly. This is the global average. And then what does this point to you? This is actually saying quite a lot, this particular data. So this phenomenon is called the urban cities CO2 dome phenomenon. And it's related to ineffective CO2 sink during nighttime and during winter. And what does it say? It says that it has nothing to do with how much you emit. About how much, the question really that is more interesting, it's about how the system can suck it down again, right? It shows you because come winter or summer, in fact, even go way below this. Should we say that we're starving from CO2 now, right? I mean, this is really something that really we should understand. And guess what? Under the United Nations Agenda 21, all these major mayors from all this city, by the way, they are not quite elected in that sense. These people are trying to introduce now, one of the main agenda is basically to cut CO2 reduction in all their urban cities. What are they really serving to propose to do here? And we'll see the results in a minute. So guess what? We now have an opportunity. We have a condition that in which that all these urban cities, which is new phenomenon in that sense because we changed the landscape of our city. And here's an example for Salt Lake Valley. Pictures from 1870s and then now for 2004, right? But we built all kinds of stuff around, and Dave Legates will talk a little bit more about urban city effects. And then look what happened, right? No CO2 dome then. Now we have CO2, very high CO2. Great opportunities for hypothesis testing again. Let's follow Galileo example. So can anyone, because winter level of CO2 is so high in Salt Lake City, that I don't think that, the Salt Lake City, whatever how they try to change the CO2 level in the air, they will not be able to do much. But the point is that, does it really have any effects on the temperature itself? Now is the temperature for the winter temperature from about 1880 to about 2008 or so. Please, someone try to tell me that you see a winter warming temperature trend in Salt Lake City because of the high CO2 effects. Again, we can find it. We can find it in a global picture. We can find regional pictures, and then later we'll talk a little bit about regional, smaller region. This is a local condition. We won't be able to see it. We just simply don't see it, actually. That's the problem. If we were to see it, I'll be the first one to tell you too, that I have seen this, and then it's really true, and CO2 is causing all this problem. But it's not. Here's another way to try to study this problem. I'm showing, because as you know, CO2 is an infrared sensitive gas. So most of the things that it's actually doing is in terms of this thing called OLR, which is outgoing long-wave radiation, which we can measure from space. And these are essentially measurements that are related to the space measurements. And these are just focus on the top two panels, okay? The T surface, temperature surface, from about 1980 to about 2005 or so, and then outgoing long-wave radiation. So if we keep increasing this CO2, we should be able to see the changes of the outward long-wave radiation increases. But guess what? We don't see it. We kind of see slight decreases. Whereas the surface temperature does change. It increased a little bit, of course. But of course, since about 1998 or so, as you can see, the temperature has been going down. So this is stopped at about 2003 or so, actually, not 2005. So again, we have another hypothesis testing, right, that doesn't really fit. And guess what? How many of you have heard the idea that they say if you add more CO2, we not only warm the surface at the bottom, but guess what? It has this contradictory phenomenon that the stratosphere is the region about 10 kilometers to about 50 kilometers or so, that this stratosphere, because there's nothing to stop this radiation from escaping because there's not much stuff there. So this escape radiation, which is the outgoing long-wave radiation, will start to cool this because more of the heat get removed by radiation. So CO2 will warm the troposphere and the surface, but it will cool the stratosphere. And now, let's go and do some hypothesis testing. Here, I show you temperature measurement from about 20 kilometers satellite base, 30 kilometers, and 35 kilometers. And I say, quick, please someone call Al Gore, because we now have proof of CO2 causing the whole stratosphere to cool. Right? That's data from about 1979 to about 1996 or so. And as you can see, this data is fairly new. It's just been published last month. But of course, since 1996, guess what? The temperature is going. It's slightly warming again. See, this is not hypothesis at all. This is really nothing. I don't even know what you call this. It's just strange stuff. But it doesn't fit, put it that way. The proof is actually not proof at all. They love this argument, by the way, and then they quiet down because they really know they don't have anything to go. This is not a very powerful argument, but it's still one of those popular arguments that they use to try to attract all these popular people who actually are less rigorous in science and won't be able to read charts so that they can confuse people easily. So guess what? The test on the surface, the troposphere, local, global, whatever you look at, I just can't find it. Someone help me, please. So I guess I was so frustrated I went to this global warming rally, right? In Wisconsin somewhere. I love Wisconsin now, so I've been going there. And then Mr. Gore appeared to accept his Nobel Prize speech. By the way, that's the booth. That's the booth from the Peace Prize in Norway, by the way. All right. Now I'm going to switch gear a little bit, talking about the sun, my favorite subject. And again, for the benefit of students here, or children, if you ask yourself, how big is the size of the Earth in this image? It's basically, if you put a quarter there, okay, it's that small compared to the sun image. So sun is really that really sole energy source for the climate system. There's nothing else could supply that kind of energy. And just to be sure, the sun, the idea that you even dare to mention the sun can affect the climate system, this is called a true lies. And on the list of basically 50 lies, according to them, that the sun is number one. All right? So you're dealing with really serious stuff here, okay? You make sure you learn something here because you'll be a true denier if you dare to even say the sun is doing anything. And then, of course, we have our wonderful U.S. National Academy of Sciences, who really used to mean a lot of things before and really don't mean that much today. And here's the president, Ralph Cicerone, is saying things like this: the sun-induced climate theory is no longer viable, with some assertive sense where he has not studied even the sun less than 2 minutes. He's just getting some advice from somebody who's really not reliable and not knowledgeable at all. So making such statement, right? It's really devastating, actually. And I'll tell you more about the personal politics of this Ralph Cicerone, but let's not get into this, okay? He's really not qualified to even be a member of Academy of Science. That's the bottom line. And actually a very good scientist by the name of Richard Linson from MIT actually has pointed out this. Anybody want to read the essay, please write to me so I make sure all of you read this, where he was reluctant, Dick Linson, to tell this story for almost 15 years. It's to show that in our National Academy of Science right now, there is this so-called temporary membership nominating committee. And guess what? It's been temporary for 20 years. It's basically to put in guys like this. Ralph Cicerone, the current president, come in through that channel because they couldn't qualify as the real member of Academy of Science because they're just not that good of a scientist. Sorry. And then now, let's do some hypothesis testing. Now I want to point your attention to the Arctic. Arctic, as you all know, is that famous canary in the coal mine where they say, if anything were to warm in the globe, you ought to warm in the Arctic first, and not only that, it warmed the fastest, the largest, right? And now let's go through some hypothesis testing. So Arctic temperature is plotted from about 1960 or so by the dotted line, the blue line, and then CO2 is rising. This looks really interesting. Wow, CO2 is rising, and then the Arctic temperature is kind of warming. Very good. Let's go about looking at the rest of the data. Guess what the problem is? If you look from about the whole data set from 1873 or so until now, you will see that, well, when CO2 changes little, the CO2 temperature is not warming, but the problem is basically this sharp warming from about 1920s to 1930s and 40s, where the CO2 it changes so little. And worse yet, from 1940 to 1970, the CO2 started to rise rapidly. Guess what happened? The Arctic temperature not only not warm, it's actually cool slightly. Does this mean that actually we're suggesting that the greenhouse effect of CO2 is making Arctic temperature to cool? It's impossible because greenhouse effect can only warm. Okay? If it can only warm and then the temperature is not warming, it's cooling slightly, what does it tell you? CO2 is really not playing that role in terms of changing Arctic temperature, period. And then now I give you a comparison. So the same picture is shown to your right, the CO2 hypothesis, and this is my hypothesis on how the light of the sun, the variable solar irradiance, over the last 130 years or so, has been really going up and down and sort of following, or actually driving the Arctic temperature. Okay? And of course, this is also statistical correlation. So I must really go a little bit more to try to explain to you. But before that, let me do another test. That was the temperature for the whole Arctic. Okay? And that's shown, repeat here, but smooth the temperature curve now by a 5 years filter so that you can see less of this weather year-to-year fluctuation noise. And then that's shown again up here to your top left. And then I also show now the data for Atlantic sector of the Arctic and the Pacific sector and the Greenland Icelandic sector. So it's a very interesting way. If you have any hypothesis at all, you test this thing. You look at the whole average over the whole Arctic, then you look into this regional pattern. Does it fit? It kind of have a similar fit, okay? And then even if you go down to small little local regional pattern, can we see anything? Here now we point to two temperature records from Greenland, okay? From the southwest and the southeast, Gotthard Nuuk and then Amasilik. It's kind of there, still there, all right? What does it tell you? From local to regional to the whole, you have kind of consistency there so far. So it's very, very difficult for me to reject the hypothesis so far. And of course, in actual scientific works, I actually this year was very proud to be able to write a paper that summarized all of this and then formulate in a proper scientific ways that can really explain to you why it's involved the ocean, which Bill Gray will talk about, and so on and so forth. But then it's all kind of related to how the variable solar output is actually affecting the climate system. And I will argue that you need no more anything than just sunlight, no fancy stuff like cosmic ray ideas, just sunlight, just worry about how seasonal light is changing on the Earth system, that you will have the whole story, okay? As long as you have some persistence. So now, all this statistical correlation, that's no good. Do we have any strong physical sense of argument how to explain this, all right? And I say, yes, we do, of course, because I follow Obama a bit. Yes, we can. We can have some rule that. No, now I try to explain to you why the sun is a far more important climate driver than CO2. This is actually the correct picture. I won't explain too much. I will use a cartoon analogy in a minute. But the whole idea is that when you study this system, you study it from the whole basis, not selectively. And I'll show you the tricks in a minute. So if you compare sun and CO2, I want to point to you that you cannot separate this so-called baseline, which is the blue bar, and the red bar, which is baseline plus change. They are inseparable. Just like you could never separate weather from season to climate. There is no such distinction. If you let those guys tell you that the World Meteorological Organization is telling you that, hey, climate is just the average, 30-year average of the weather, good luck, okay? No one has the authority to even come close to be able to define climate that way. Completely wrong in that sense. I'll show why. So this is the correct picture. But let's use a cartoon analogy. Imagine that Tom Brady, the New England quarterback, he's the climate system, right? Imagine then the sun is that big gorilla. He's on diet, drinking some water. And CO2, who's that guy? Willie. He's greedy. He's eating a lot of hamburger, gaining some weight, all right? So that's what they mean by CO2 increasing a lot, and then the sun changes so little, and sun couldn't possibly push the climate system. So imagine that. Who will be more effective in pushing the climate system? Even if this guy go on diet a little bit, I'm quite sure he'll be able to push Tom Brady. And then if you ask Willie Soon, CO2, to go and push the climate system, guess what Tom Brady will do? He actually push me back. It's controlling. This is the idea of how temperature is actually controlling the CO2 level itself. Because as you all know, we emit 100%, only maybe 30% is left in the atmosphere today. And then 70% will come back out because it's completely controlled by the biology and the whole climate temperature itself. It's not so simple stats. In fact, the originator of this famous Charles Keeling curve has already won in 1995. We should not be so rushed to the judgment to try to say that, oh, if we put all this CO2, we know how the future level of CO2 is going to be. We don't. We just don't understand the global carbon budget well enough to try to specify that. And of course, politicians know otherwise. But this is actually the correct picture. But now let me come to the trick. Do you know why for so many years they can keep insisting that, their CO2 is right? This is the picture that they're trying to tell everybody to believe in. The picture, they say, we should not talk about, when we talk about climate, we should not talk about anything but climate change. Kind of true, isn't it? Climate always change and always will, right? So they say we should only look at the difference of the forcing instead of the correct picture that I was trying to point to you. They say we should only look at the change. Okay? And guess what you're committed to in this picture? You're committed to, in this picture, so CO2 is very big, 1.7, because the difference is really large, right? Because I'm eating a lot of hamburger. And then the sun, drinking water, gain only very little. This number I can challenge, but for now I won't challenge because I just take it from IPCC. It should be about 1 or so. But even that, It's kind of persuasive. They're trying to do that. But guess what you're committed to if you believe in this picture? You're committed to a system in which there is no weather, no sunlight, no season. Don't even have climate. Because everything is just climate change. I'm sorry, I don't think I believe in a system that works like that. Okay? So I really think that argument, in fact, I invite all of them. My favorite moment was actually in Oslo in August last year, in front of all this IPCC audience, where there was no scientific comment. The only thing they were angry about is that why do I get to stand up there and talk to 1,000 people? So I don't know what to say about that, but I'm telling you that their picture is kind of weak. I wouldn't understand the argument, but then this is their argument. So that's the role of science, of course, is try to explain why they see it this way, why I see it this way, and then you can agree to disagree and probably try to come to some kind of resolution. But I clearly think that cutting CO2 is just not going to get us anywhere, which is a very strange phenomenon. So now just a little bit more about sun-climate connection. I've been studying this for many, many years, and this is just another example that was already shown in Robinson and Soon paper. We show the U.S. temperature history by the blue line, and then the same solar irradiance curve by the red line. Okay, so you can see if it's a hypothesis testing, guess what? If you see it in Arctic, maybe you can see it somewhere else. USA, we see it too, roughly. And then I'll show you even more dramatic example, which is from Florida. I didn't know that such a movie exists, but of course, Florida is that sunshine state. And here's the temperature from Tampa Bay, because I was just testifying in one of this, somewhere in Lakeland, one of these places in Florida that talk about the Electric Utility Commission, that they asked me to talk about CO2 effects on climate system, and I guess they were shocked that I was able to show them things like this. That the temperature curve is the blue one, and then the solar curve is the red one, the same one again. It's very, very strong correlation, by the way. It's extremely strong. If you want to see it, I help you by smoothing it by 10 years. This explains up to 83% of the variance, which is very, very impressive. Okay? Which means that this thing has a very, very good accounting of how things can change up or down. Okay? But again, we don't have enough data, but we need a full hypothesis that could be rejected, and I'm formulating that now. In fact, I published already a paper on that, on those issues, so more works to be done for sure. But guess what? Can anybody tell me that you will find CO2 effects in this? Please. I mean, I don't think so. It's really a lot of problem. So my report to you and to Galileo is that indeed, this claim of death or the influence of our suns on the climate has been greatly exaggerated. Okay, so be aware of all this popular claim and TVs and medias and all that, or some expert out there. Tell them to talk to me. And then I think if we were to ask Galileo or even my friend David Legates, that I would say global warming is baloney in that sense. And 24 hours, of course, you can get all the information. Now up next will be my friend David Legates, or maybe Fred Singer will go first, but I happen to plan it this way that Dave will go next. He is really one of those most underrated but the most brilliant climatologists that I know. And we got a connection here between global warming, Legates, and Galileo itself. So please pay some attention to Dave Legates. Thank you. Do we have time for questions? Okay, question please. Come up to the mic. Please come up to the mic. You go first, Paul.
Willie, when you spoke in Oslo to the IPCC, what was the reaction of the audience when you were done, please?
To tell you the truth, it was a lot of roar and noise. There was a lot of support. Remember, this is the International Geological Congress, which is the Olympics of all the world geologists. We have almost 20,000 people there. And it is one of those plenary sessions that I was lucky because one of the organizers that put me in, sit me in, but once again, 10 of them. Usually, that's the way it works now. Okay, we can get one person in, you are lucky. The reaction was, I'm sorry, no science. They were not interested in having the civil exchange. One guy was literally shouting because he was representing the Canadian Climate Modeling Group, was shouting that, how dare you speak here, IPCC, I belong to the IPCC, and so on and so forth and all that. In fact, some of the things that I show was directly criticizing the people who wrote the paleoclimatology section. I know the guy, his name is Jan Einstein. He's sitting in front of me. Face-to-face, eye contact, no question, that cold. Like this. It's just weird. I don't know. I think the reaction was they were kind of surprised what I'm able to tell them. And then somehow, in a lot of strong sense of anger, that how come we can still make sense? That, we kind of, and then they refuse to engage. That's the experience that I have. And I I'm, I guess, tired enough. I used to not like, quote-unquote, debate. Now I'm open to all debates. The problem is that I realize that if I don't do this debate also, you will not get things going. You will not get the truth to be out there. Because we really need to engage them to come down to a point where they can admit something, we can admit our weakness if something is wrong with it. I have no problem. In fact, I have no stake at all on any variable changing the climate system. Okay, I'll rule out aliens, of course. I mean, that one, our late Michael Crichton has done that very well. No alien doing that. But I really, really don't know. The feeling is that. So in December of this year, with Dave Legates and another professor from Stony Brook, we're organizing a scientific session, which is essentially to the theme that I want scientists to take back science. So we got to fight very hard to try to create a science session for ourselves. Essentially, we're trying to get as many skeptical viewpoints to present paper there, so eventually we'll publish. In fact, we open everybody. We invite them to come, of course. But I'm not going to invite them as invited speaker because they're not worthy. They're not as good. I'd rather get Dick Linson, right? So things like that. That's one step in the right direction, which I hope will work out fine, but we'll see. Howard?
Willie, you were right that there's at least 90% skeptics in the audience. Some of them are even more skeptical, such that they might be skeptical about your hypothesis that it's solar irradiance. You showed brilliant correlations, but solar irradiance itself might be correlated with solar magnetic fluctuations or with solar wind. So you haven't proved that it's the solar irradiance and not those other two phenomena that cause the fluctuations.
You are right to some level on that point. And I'll just definitely encourage, I will send you the paper to read, of course, of a real hypothesis in which is rejectable. And it's not that correlated. It actually is more like the magnetic flux is causing the irradiance to change. Okay. Right? So.
Hey, I love your work, Willie.
Valid criticism.
I've got an observation and a question. And one of the pivotal moments I saw in your presentation was when you mentioned that science is affected more by persuasion than by proof.
Right.
And of course, I would enter pseudoscience is affected more by persuasion than by proof.
Right.
And
I'm pointing to the difficulties because at any given moment, it's a conjecture, Copernican system. We don't have the absolute proof because we don't have. You really take a system that we can really measure all of things accurately. At that time, 17th century, they really don't have it. Really, it's just by really a very persuasive argument, really.
And
rather than actual proof.
From talking to you and you talking to me in the past, my interest in what is a proof and the concept of objective reasoning. And my desire and interest in this is more in terms of how to be persuasive. I mean, ideally, we should be persuasive through the scientific method. However, it seems that emotion runs the world and that reason is the servant of emotion when it really should be the other way around. But my question, you mentioned these probes that I think go down 200 or 2,000 meters?
Correct.
And come back up. Could you just mention a little more about that for about 30 seconds? Because I don't.
Oh, sure. It's basically the oceanography community is deciding that we really are so lacking in information. If you were to ask, they like to say that okay, we know more about planetary bodies and information about moons and all that than our ocean itself, which is kind of true, really. Lower part of the ocean has really essentially no measurements at all, no data really. So these are efforts that is very much more a step in the right direction to try to collect all the information, measure just about anything, flow directions and salt and what have you, that we really need that information to start deduce it. But at least the first sign of the data is clearly telling you quite a lot already about the ocean heat content. How does it change? And remember that they keep saying that you increase the CO2, you must increase the ocean heat content. But the fact that it's not doing that, really, really one of the biggest. The discrepancy is so big now, they really have difficulties. Okay, unless there's some flaw in the data, of course. Howard?
This month, the climate has changed for Livermore scientists, as advertised in this newspaper, and they claim that because there are fewer attacks personally on the Livermore scientists that are persuading that the climate change requires immediate action because it's rapidly warming and humans have caused it, that therefore they are winning, that because there are fewer attacks now, they are persuading the public. In fact, do you notice that there is any greater persuasion that there is dangerous human-caused climate change than there was in the public view of it 10 years ago?
Oh, clearly the data and the actual weather condition itself is not helping them. I mean, clearly that large majority of people, I mean, I'm the last person to believe in all these polls and all that stuff. All I know is that a lot of people are sort of getting even more skeptical in that sense. But the problem is that these people really need to have the courage to stand up. I really think that we cannot be these closet skeptics. We really need to step up and go to all our community, go to all our high schools and grade school, whatever it is, that anything that you have a chance to talk about this, you just talk about it and present some facts and invite them to come in and talk about their facts, and then let's present people.
Do you know is greater or less acceptance of Gore's?
Oh, a lot less. People know that Gore is a fake. I mean, in March of this year, I actually have the distinguished honor to be able to sort of pose a question to him at the rent-seeking conference in Santa Barbara. It's the Wall Street Journal's economics conference. The only reason I almost did not go because on the ground of just crazy, to go this for what? But I felt that I can still make a little influence. They invite me to be leading discussion on topics of factors of climate change, so I go there. But I asked Al Gore the questions. First of all, I give him a little small lectures about how I disagree with his language. I may not be a good English speaker, but your language is foul. CO2 you call pollutant? Oh, it cannot be. And things like that, so on and so forth. Then finally I asked him the question, Mr. Gore, what will we get? Can you tell us, please? What will we get by lowering CO2 emission? He refused to answer. And then he was going on, what's your name again? Willie, soon I keep repeating. And then he ultimately answered in a very funny way, which I gained a lot of friends even from the rent-seeking people. I get almost 100 name cards of all these big CEOs who I really don't care for, but they come out and give me a card, okay, thank you. And then they say they disagree with Al Gore, but Al Gore answered this. He said, how about the chance, showing face like this, how about the chance to save humanity? Okay, I said, thank you, sir. I said, me too. But anyway, he was really a bit nasty on this, and I don't know where he's going with it, but he's not persuasive, period. This is why in all this contract that he's going to give all this public speech, he will take the money, but he will not allow press to ask questions. You tell me the contract. I mean, if anybody wants to see the contract, again, contact me. We have his contract that you can read for yourself.
Then their claim that they're winning the public over is more propaganda.
Yeah, it's false. Yeah, thank you. Let's go on to the next one.
Dr. Soon, I really appreciate your talk. I was wondering about the different methods for measuring surface temperatures and also for tropospheric temperatures, because I've heard that if you measure the temperature on a mountain, it's still a surface temperature, even though it's a higher elevation. And so that can kind of skew the
these sort of questions is really, it's a very, we don't have a satisfactory, this is why temperature is not really a very good metric at all in that sense. Because again, depends on where you are, right? And then so things, we should really get some information like heat content, heat, in joules units, where if we can measure those things, then we're in good shape. And then as to measuring things from troposphere, as you know, the method is through watching vibration microwave, like, microwave of oxygen, so you measure that. And then some of the stratosphere one, they use infrared radiation, in fact, from the CO2 band itself, which is 15 microns. So all kinds of methods of measurement, and then surface one, mostly thermometer, of course, or you can put your hand out there, of course, but you don't have a quantitative ways. And then more sophisticated instruments, sensors, and all that for this Argo stuff, which is, of course, it's a lot more accurate and more better way of taking data, of course.
For measuring the troposphere, I read about a balloon method. What's the balloon
Yeah, balloon
method?
Also is more in situ, right? It's just a balloon going out. It's
a helium balloon?
Any balloons, right? Balloon that just lifted up, but the whole thing is the instrument, right? It's one of these thermometer, really.
And then how do they measure solar irradiance?
Irradiance is from satellites. You got to go above the Earth's atmosphere. You actually have a black box, pin everything inside, and then have a little pinhole, and then sense how much radiation come in, and then if you know the size of the relative, you can try to deduce some information.
Okay.
That's really a very simple method, by the way. It's just the problem of sustaining the measurements and maintaining the calibration, which is a really hard work. This is the part where, where you really, because of all this, what you call applied science approach, that is really destroying science quite a lot, because we ended up not doing anything. They are not committed to provide real data where we can get the real information. They are giving patchy little small project here and there, measuring all kinds of stupid things that doesn't mean anything, that nobody knows how to put it together. This government Ryan science is really going crazy, put it that way. I'm so against it too.